Okay, y'all. So 2-2. Biggest problem that I see in 2-2 has to do with this word right here, solving. So you see that we're dealing with quadratics, and this first part says solve by factoring. So we have already factored this year, but now we're going to add the solving part into the mix. So this is an easy one to factor. So I end up with x, well, easy one, and then I make a mistake. So x minus 3, x minus 2, and this whole thing equals 0. So negative times negative is positive 6, negative 3 plus negative 2 is negative 5. Okay, now at this point we have to solve. So I'm going to make a couple notes here. First step in everything is that the quadratic, and it's not even quadratic, any function must equal 0. So this already equals 0, so we don't have to worry about anything. But we have to have it equal to 0 when we're solving. When we're factoring, we don't have a 0 over here. We don't have this equal sign. Okay, so when we're solving, we equal 0. Now we're going to set each piece equal to 0. So here's what this looks like. X minus 3 equals 0, and x minus 2 equals 0. So when we're doing this, x minus 3 or x minus 2 equals 0, we're saying that if this part of my factor was 0, then the whole thing has to be 0. Or if this part of my factor is 0, then the whole thing has to equal 0. Because we know anything times 0 would equal 0. All right? So if we set each factor equal to 0 and we solve, we get x equals 3 and we get x equals 2. So these are my solutions, x equals 3 and x equals 2. And now let's talk for just a second about what this means. So when we're solving a quadratic equation, we are finding the factors, but we're also finding where we have an x-intercept. So this x-intercept is also called the 0 of the solution, and it's also solving. So if I look at this, what this is saying, if I was graphically going to solve this, is that I would have my quadratic. I know that this is a quadratic, which is going to be a parabola, that this quadratic is going to cross here at 2, and it's going to cross here at 3. That's what this is saying graphically. Okay? Now, what we're doing right now is we're just solving the zeros, but I think it's super important to understand what this means. So what this means is when x equals 2 and x equals 3, I know that this quadratic is going to go up because my a value is equal to 1, so I'm going to have something that's going to look like that. Okay? So now that you understand what we're doing by solving, by factoring, we're not going to graph these. I just wanted to make sure you understood this. Okay, so let's go to part B. So part B, step 1, everything has to equal 0. So this guy has to move over. It doesn't equal 0 right now. So I'm going to have 4p squared minus 26p plus 40 equals 0. Now, the placement of this is super important because this is in standard form, so now I can factor it. I'm not just going to stick this 26p on the end. I'm not going to say 40 minus 26p. That's going to change your factors, and so we don't want to do that. Okay, so if I look at this, I know I can pull out a 2, right? These are all even, so just like when we were factoring, I want to pull out a GCF, and I'm left with 2p squared minus 13p plus 20. Okay? All right, so next step is I need to factor this guy on the inside. So I'm going to have 2p, and I'm going to have p, and my two numbers here are going to be 4 and 5. So I see that I have 8 plus 5. So I'm going to have 4 here and 5 here. This is negative. This is positive. I know my signs are the same, so I'm subtracting both. Okay, so this gives me negative 8 minus 5, which is negative 13. Okay, so I'm doing okay. All right, so now let's talk about this guy. So we factored out this 2, and there's no variable with it. It's just the 2. So I can take this 2 and I can divide it out on both sides, and if I do that, I get 0 divided by 2, which is still 0. So a quick cheat on this is whenever you factor out just a constant, it has to be just a constant. It's going to be different if there's a variable. If I factor out a constant, then I can just pretty much get rid of this when it comes time to solve. Okay? So that goes away because what I'm doing is I'm dividing this by 2, and 0 divided by a number is going to stay 0. That's why that works that way. So now, this time, this is a little more funky than this. I just move this 3 over and I get x equals 3. Well, now I have this. So what happens is I have 2p minus 5 equals 0. As I solve this, I move the 5 over and it becomes positive, and then I divide. So I'm going to have 5 over 2, and I'm going to have 4 because this one's simple. Now, let me caution you. The biggest mistake that I see is that when you see this factor here, p minus 4, people are going to think that the solution, that the x-intercept, that the 0, all of those things are saying the same thing, is going to be negative 4. It is not negative 4. We have to take what makes this 0. Well, positive 4 minus 4 is going to be 0. So if you need to do this step where you write it out and set it equal to 0 so you don't make a mistake, initially you can do that. But what you're asking yourself is, okay, if this is going to be 0, I can't have a negative 4 here because I would have negative 4 minus 4, which would be negative 8, not 0. Okay? Super big mistake. Doesn't look like it, but I guarantee people make that mistake. All right, so here we are. We're at the next one. So it equals 0, so I'm good to go. What I notice here is that I have a difference of squares. 16m squared and 25, difference of squares. So when I factor this, I have 4m plus 5 and 4m minus 5. Now, what I'm going to do is I'm not going to write this out. I know that my m value, I'm going to move this to the other side of the equation, so it would be negative divided by 4. So negative 5 divided by 4. Same thing here. I move the 5 over, so it's positive 5 divided by 4. So I have two answers. And just because it's a perfect square, you need to make sure that you logic through this to make sure that both your answers are going to be the same, positive and negative. Okay. Come over here. I have two terms, but this is not a difference of squares because this is not squared, and neither is the 6. And it's not cubes because this is not a cube. So I have to use GCF. So I'm going to pull out an x squared, and I'm left with 6x minus 1 equals 0. Okay, so let's talk about this first. I have to have this minus 1, right? Just because I pulled out this x squared, it doesn't go away, right? So think about it. If you were to distribute this back in, I would have 6x cubed. If I would distribute this back into the negative 1, I would have negative x squared. Okay, so super important. Now, if we look at what we did in part B and we look at what we have in D, these are not the same. And I know you say, well, we factored out a number, but we factored out a number, a constant. Now, what we've done is we factored out a variable. And when we factor out this variable, we can't just cross it out and say that it goes away. What I have here is x squared equals 0 and 6x minus 1 equals 0. This actually is a variable that's going to equal 0. This one didn't, right? Super important to see the difference between these two. So what I know is if I take the square root of both sides, I get x equals 0. And with this guy, I get x equals 1 over 6. Move the 1 over, it's positive, divide by the 6. Now, what you're going to notice is I have this written a couple different ways. I have x equals 0, x equals 1/6. I also have it written this way. These two things are saying the same thing. So you can write it out as separate x's, which is really a good thing if you're separating them out to solve them, or you can look at it and say, okay, m equals both of these values. And y'all, this m here is not slope. We're using m because we have m here. All right, so two different methods here to solve this basic quadratic equation. So I'm going to do what I would think is the hard one first, okay? So we know that when we solve, it has to equal 0. So I'm going to say x squared minus 16 equals 0. And now I have a difference of squares. So I have x plus 4, I have x minus 4, the whole thing still equals 0. So now I know that the opposite here, my two solutions are going to be negative 4 and positive 4, and I'm done. Okay? So now let's go over here and talk about this one. So this is a perfect square, and this is a perfect square. So if I know it's a perfect square, if I do one thing to one side, I can do it to the other side. Okay? So if I take the square root of this side, and I take the square root of this side, then what I get is x equals 4. But let's talk about this for a second. If I plug 4 in here, I get 4 times 4, which is 16. But I can also plug in a negative 4. If I get negative 4 squared, I would have negative 4 times negative 4, which is also 16. So when we do this square root method, what I'm doing is when I take the square root of this, let me put this here so we don't get confused. I would have the square root of 16, but I would say positive 16 or negative 16. So my answers here are going to be x equals negative 4 and x equals positive 4, which is the same thing that we had over here. And the reason for that is because when we do plus or minus the value, that means we have a positive 4 answer and a negative 4 answer. Okay? Now, I don't care if you leave it like this, positive 4 and negative 4, and I'm going to talk more about that and why it's okay to use this nomenclature for me when we get a little farther in. Okay? So, non-factoring method. So I'm going to use this square root method here. So this is squared, and this is a perfect square. So I can do this. So if I take the square root of this side and the square root of this side, what I get is x minus 2 equals plus or minus the square root of 16. You have to use this plus or minus. So I would have x minus 2 equals plus or minus 4. Well, now at this point, I guess I could have dropped the parentheses here because we're all done with this, but it has to be x equals. So x equals, it has to be x equals. So I have to move the 2 over. So what I end up with is x equals 2 plus or minus 4. Okay? So if I do this, 2 plus or minus 4, really what I have is x equals 2 plus 4 and x equals 2 minus 4. Let's talk about this for a second. If this are plus or minus 4, this value of 2 doesn't change, but I'm going to add 4 and I'm going to subtract 4. So this would be 6 and this would be negative 2. So my two answers here are going to be x equals negative 2 and x equals 6. Okay, so non-factoring method. So I take the square root of both sides. So this gives me x plus 1 equals plus or minus the square root of 3. And this looks really funky now because this 3 is not a perfect square. So I can't go in and simplify it like I did over here and make square root of 16, make it 4. But the process is the same. I still want this x equals, so I have to move the 1 over. So what I end up with is negative 1 plus or minus the square root of 3. This is my answer. Now, let's talk about what this really looks like. What this really looks like is I have two answers. Negative 1 plus the square root of 3 and negative 1 minus the square root of 3. Okay? Now, we're not going to simplify this. If we had a calculator, we could, but we're not going to do it. We're going to leave it just like this. All right, so because we're starting to get radicals in here, this is a little review on simplifying radicals. Remember, a radical is a square root. So, you know what? I want you to go in and solve these. I'm going to pause the video, and then I'll come back and talk about them. Okay, so go work those. Okay, here's what we have. Let me talk about a couple of these. 13, that one's easy. Here I separated into 9 and 2. Here I separate it into 6 and 4. This does not simplify anymore because all we have here is 2 and 3. We don't have a pairing. Okay, let's get over here. So here's one that's kind of want to talk about. So when I see 72, so in my mind I know this is 36 and 2, but most people say, okay, 9 and 8. But 8 is not a perfect square. 8 is not a perfect square. So if you did this, if you did 9 and 8, you would have 3 square root of 8. Okay? But you're not done because this separates out. So I would have 4 and 2. So what happens is I bring this 4, I would bring the square root of 4, which is 2, I would bring it out front. So I'm going to have 3 times 2 times the square root of 2. Now hold on. This 2 is the one that's on the inside, and this 2 comes from the 4. Well, I don't leave this as 3 and 2 out here. I'm going to multiply those together, and I get 6. So if you get to a point where you're simplifying a radical and you can keep going, keep going. That just means I can separate this more into 4 and 2, and I pull out another 2. Now the key is you've got to multiply anything that you pull out front. And then it's easy to test this, right? So if this is 6, and I pulled it out, that means what I had is 6 times 6 times 2, right? I pulled out 1 6, which means underneath the radical, I would have had 6 times 6 times 2, and when you multiply this all back together, you get 72, which is what you started with. So it's easy to go back and forth and check it to see if you're done. Okay? All right, this looks funky because it's a fraction inside the radical, but this just means you separate it. Take the square root of the top, the square root of the bottom, and I get 10 over 9. With this one, I take the square root of the top, I take the square root of the bottom, and unfortunately, that means I have a radical in the denominator. So we can't leave it. So to clear the radical in the denominator, you multiply by the same value. Whatever I do to the bottom, I have to do to the top. So if I have the square root of 5 times the square root of 5, it equals 5. Up on the top, I have the square root of 3 times the square root of 5. I keep that underneath the radical, and I get the square root of 15. Now 15 doesn't simplify. So it's okay to have a radical in the numerator. That's okay. We don't want a radical in the denominator. Okay, so now let's flip this over and look at this completing the square. So we've done completing the square. We've done this. So what we're going to do now is we are going to work this, and here's my key word again. We're not just completing the square, but we're actually solving it. All right? So if you remember our steps, my constant gets moved to the other side. So I have x squared minus 4x equals 8. That's the step 1. Isolate the x terms. So the x terms are on one side. Okay? I can't pull out a GCF. I take half of the middle term. So I take this b term, I take half of it, completing the square. I end up with 2 squared. I like to leave it this way, and I'll show you why. So my value of 2 is what this is going to become. So I have x minus 2 squared, right? So it's subtraction because this is subtraction. So x minus 2 squared. On the other side I have 8, but now I'm going to add 4. So this squared is what comes over here on this side. Just the 2 is what goes inside my my parentheses here. Okay? So now what I have is x minus 2 squared equals 12. And now I have this squared value over here. So if I take the square root of this side and the square root of this side, I end up with x minus 2 equals the square root of 12. And this is actually, hold on, let me go back. I know better, plus or minus 12. Because I have to have the plus or minus when I do this. Okay, 12 simplifies, so I have 4 and 3. So what I have is x minus 2 equals plus or minus 2 square root of 3. And then my last step is to get the x by itself. So I move that x over, and I have x equals 2 plus or minus 2 square root of 3. And this is my answer. Okay, now again, I did this on the other side, but let me do it again. What this means is I have 2 solutions. X equals 2 plus 2 square root of 3, and x equals 2 minus 2 square root of 3. That's what this is saying. Super important to see that you still have 2 solutions. Okay, let's look at B. So with B here, the first thing I'm going to do is move this over. So I would have 4x squared plus 24x equals 13. All right. Now, when I see this, what I see here is that I can factor out a 4. So I'm going to do that now. I'm going to factor out a 4, and I have x squared plus 6x equals 13. Okay. Well, even though this is a 4 over here, and I could take the square root of it, I want to get rid of the 4 next. That's the next step. So I'm going to have x squared plus 6x equals 13 divided by 4. Okay? So now I'm going to go in and I'm going to take half of that b term, which would be 3 squared. So here's what I end up with. I end up with x plus 3 squared. Remember, I take half of the b term, and now I have x plus 3, this whole quantity squared, equals 13 divided by 4 plus 9. Okay? Now, the next step is going to be take the square root of both sides, but I'm going to simplify this guy first. So I have 13 over 4 plus 36 over 4. So common denominator. So I have to add this, and I get 49 over 4. Okay, so let me rewrite this now. X plus 3 squared equals 49 over 4. Okay, so now I can take the square root of this side, the square root of this side. Now remember, we just did this. This is the same as saying the square root of the top and the square root of the bottom. All right, so I'm going to skip a step here, and I'm going to actually simplify this, and I'm going to have x plus 3 equals plus or minus 7 over 2. All right, so now I move this 3 over, and I have negative 3 plus or minus 7 over 2. Now this is one that we can actually simplify this, right? And here's why, because this is not, this is easy fraction math. So if I do this, I have negative 3 plus 7 over 2. Well, if you know what 7 over 2 is, this is the same as 3.5, right? So if I have that, then, yeah, 3.5. So if I have this, then my answer here, this part is going to simplify to 1/2. If I look at the other way, I would have negative 3 minus 3.5. So I have these two values. So if I plug this in my calculator even, what I'm going to get is that x equals negative 1/2 and, let's see, 6.5. All right, so here's what I'm going to do. I'm going to pause the video, and I want you to try letter C. Okay, lots of stuff going on this one. It doesn't turn out to be as pretty. So what happens is we move the 1 over, we factor out the 3. What you get here is x squared minus 2. Remember, the next step is divide by the 3. So I get negative 1/3. All right, so then I take half of my b term and I get 1. When I write it, my completing the square format, I have x minus 1, whole thing squared. Negative, because this is subtraction here. Negative 1/3 plus 1. So this fraction, I converted, I did the math right here, and I get 2/3, because this is the same as 3 over 3. Right, so I get 2/3. I take the square root of both sides. X minus 1 plus or minus 2 over 3. Now at this point, what I did is I rationalized this because it's not a perfect square, so I have to multiply the top and the bottom by the square root of 3. And that's where this comes from. X minus 1 equals the square root of 6 over 3. Then I move the 1 over. So 1 plus or minus the square root of 6 over 3. That's a tricky one. Okay, so imaginary numbers. So we simplified this. I know it's not pretty, but they're going to get more complicated because now we're going to add some imaginary numbers in there. So here's the big thing that you have to remember. Square root of negative 1 is I. And I'm going to go ahead and put this one on here too, that I squared equals negative 1. So both of those are super important. I think the two most important ones that you can remember. Okay? So let's do the same thing. I'm going to pause the video, you work these 4, and then I'll come back and we'll look at answers. Okay. So I'm going to talk about C for a second. Hopefully you see A, b I separated out. Make sure you went all the way to 16, which brings you a 4 out front. So here I already have a 6 out front. So if I separate this out, I have negative 1 times 4 times 3. So with this 4 right here, I know that this is 2 times 2. So I'm going to pull a 2 out front. When I pull that 2 out front, I multiply it by the 6 that's already there. So this is where 12i comes from. Right, with a fraction, I separate the numerator, the denominator, so I get 4i over 5. Okay? All right, so let's look at these. So with this, what I have here is I've got this fraction that's not a perfect square. So what I'm going to do is I'm going to rationalize the denominator. So I'm going to say the square root of 7 on the top and the square root of 7 on the bottom. And this gives me the square root of negative 14 over 7. Okay, now we can never, 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 in fact, I'm going to put this over here, never reduce inside a radical. We're going to never reduce inside a radical. So even though I can pull a 7 out, this is not underneath the radical. If they were both, like over here, I could reduce, but I can't now. So the only thing I can do is pull out this negative. So I end up with I square root of 14 over 7. Now I can write it like this, the whole thing over 7, or I can just say I square root of 14 over 7. Either way, it doesn't matter, okay? All right, so I have the same thing over here. So multiply by 3, multiply by 3, and I'm doing 3 so that I can get rid of this 3 in the denominator. So this gives me the square root of negative 24 on the top and 3 in the bottom. Now, this can reduce. I can reduce this. So I'm going to use 4 and 6. Right? So 4 times 6 is 24, and I know that 4 is a perfect square. So when I pull this out, I'm going to pull out a 2, and I'm also going to pull out this I from my negative. So I have 2i square root of 6 all over 3. And again, can never reduce inside a radical. This can't reduce. Okay? Now, let me do something here. If I go over here and I say 6i square root of 6 over 3, let's say I pulled out a 6 instead of a 2. This can reduce. This is on the outside of the radical. So this would reduce to 2i square root of 6 because the 3 goes into the 6. Nothing happens on the inside. Okay? All right, so now this one says we want to solve this by completing the square. So I'm going to say x squared minus 4x equals negative 5. So complete the square. That's where we isolate all of my x terms. I can't pull anything out. So I'm going to say 4 divided by 2 is 2 squared. So on the left side, I end up with x minus 2 squared. And here's why. This is 2. This is negative. So I have x minus 2. On the right-hand side, that negative 5 is there, and now I'm going to add 4. So this 2 squared is my 4, so this gives me x minus 2 squared equals negative 1. All right, so my next step here is to take the square root. So this gives me x minus 2 equals plus or minus I. When I took the square root, remember I still have my positive and my negative values, but the square root of negative 1 is I. So when I move this over, 2 plus or minus I. Okay, now the third way that we can solve quadratics, and remember what we're solving, is with the quadratic formula. And so if you have me in class, you're going to hear me sing-song this. I'm hoping that gets in your brain and you never forget it. So quadratic formula. First thing you have to have, this has to be in standard form. And the reason why we have to have it in standard form is so that we're pulling out the a, the b, and the c from the right coefficients. So my quadratic formula is this. I'm going to sing the song. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I know, stupid. Hopefully it gets stuck in your head and you hate it and you remember it, okay? So here's the formula. If you're not going to sing it to remember it, you've got to memorize it. It's never going to go away. You can solve all of these problems with the quadratic formula, every single problem. I would tell you don't do that because the math is going to get more complicated. So without a calculator, you don't want to do it that way if you have another option. Okay? So solving using the quadratic formula. Step 1 is put it in standard form. So I'm going to move everything over. X squared minus 2x minus 1 equals 0. Again, because we're solving, this whole equals 0 part is super important. So that's why we move everything over. Okay? So now I'm going to identify. So here's my a value. My a value is 1. Here's my b value. My b value is negative 2. And my c value here is negative 1. Okay? So you don't need to do this. You're going to be able to look at it. It's just I wanted you to see that when there's not a coefficient, when there's not a number in front of the variable, or let's say there's not a c value, the c value would be 0. All right? So x equals negative b, which is 2, plus or minus the square root of b squared minus 4ac all over 2a, so 2 times 1. Now, this one has easy numbers. You probably didn't need to write out all of these steps, but that's okay. So what I have is 2 plus or minus the square root of 4. So negative 2 squared is 4. And then here I have negative 4 times negative 1, which is a positive 4, over 2. So I get 2 plus or minus the square root of 8 over 2. Okay, one more step here, and that's that this simplifies. So this gives me 4 and 2. So I have 2 plus or minus 2 square root of 2 all over 2. Wow, lots of 2's. Now, I hate that this first example has 2's everywhere. But what you're going to see is that because this 2 and this 2 and this 2 are all outside and underneath the radical, they're all going to simplify to 1's. So this becomes 1 plus or minus the square root of 2. And that's my final answer. So this 2 separated here, this comes out, and we have negative 1, or sorry, positive 1. And then this 2 reduces to this 2, so it kind of goes away, which means my denominator's gone. Okay, let's do another one. I have to move everything over because it has to equal 0. So 3x squared minus 12x plus 4 equals 0. All right, so next step is quadratic formula. So x equals negative b plus or minus the square root b squared, which is 144, minus 4 times a times c, all over 2a, which is 2 times 3, which is 6. So you see that on this first one, I wrote every single number down so that you could follow me. But on this one, you can start doing some of this in your head. So here I have 16 times 3, which I know is 48. All right, so x equals 12 plus or minus. Now I have 144 minus 48. So if you need to go over here and do this little sidebar on this so that you get the answer, because right now we're still not using a calculator. So if you go and do this, then you see your answer here is 96 divided by 6. Okay, now this gets a little bit more tricky. This is why it's important to know what your perfect squares are, if you know your perfect squares. So I know that I can put a 4 into this, but it can probably even go more than that. So think about what your perfect square is that you can divide into 96 that's bigger than 4. Okay? So I'm going to say it's probably going to be 8. So 4, 16 into 96, what's that give me? 6. Okay, so what I have here is 12 plus or minus 4 square root of 6 all over 6, right? Because 16 times 6 is 96, and that's where this comes from. So I pull the 16 out. This is where the 4 is. 6 is left. Now, I can reduce this, and this is still x equals. I can reduce this. 6 goes into 12. 6 goes into, or 4 and 6 can reduce. I'm going to write this 2 different ways. So this is one option. I can say 2 plus or minus 2 square root of 6 over 3. Super important. This stayed a fraction. This didn't stay a fraction. Okay? The other way that I can write this is if I use 3 as my denominator, I would have 4. If I use 2. I'm going to have to use 2. So it would have 2 plus or minus 2 square root of 6 all over, oh my goodness, Shannon. Sorry. This is going to be 3. So that would be, it would be 4. Why am I having a brain fart? If I divide by 2, this becomes a 2, this becomes a 3, this becomes a 6. Sorry. There we go. Either one of these works. Sorry, that was awful math, but that's okay. I was having a moment. All right, last one. Last one, I'm going to move this over, so I would have x squared plus 6x plus 13 equals 0. Okay, actually, you know what? I'm going to pause this. I'm going to solve this, and you solve it, and we'll check our answers. Okay, lots of math on this. So I moved it over, used my quadratic formula. So I use my quadratic formula when I subtract this out. Over here, I did a little sidebar. I see I get negative 16. The square root of negative 16 is 4i. Now, because these are all divisible by 2, oh my goodness. I am killing myself today, y'all. This is crazy. This should be 3. So 2 goes into 6 negative 3 times, and 2 goes into 4 2i. This is negative 3. Ay, ay, ay. Okay. Good thing we're done with that, since I made 2 mistakes there. So hopefully you understand my reducing errors, because that's where my mistakes were in reducing in both of these. But hopefully you see I fixed myself, so we're good. If you've got questions, come see me.